So section 3.7 is solving radical equations. And the excitement is palpable, palatable. I feel the excitement through the wires of the computer. Okay, here's an example of what I'm talking about. The square root of 3x plus 1 is equal to 5. How do we do this? Anybody have a suggestion? Anybody have a suggestion?
You square root the 5?
No, I think you just used the wrong word. That's
Yeah,
not what you mean. You mean something else, right? You
No.
square.
Yes.
You square both sides of the equation. That's what you meant, right?
Yeah. So the thing
Okay.
the square root could
Okay, let's draw a line. As we always solve equations, you should always keep the original because you never know when you may need it. Square both sides of the equation. And when you square a square root, remember we've done this a million times. When you square a square root, you wind up what's in the radical sign. And that will be equal to 25. And then negative 25, negative 1, 3x equals 24. It comes out like really beautiful, right? That's no coincidence. X is equal to 8. Now, in this type of equation, it's a good idea to do the check. So let's do the check. The square root of 3x plus 1 is equal to 5. Substitute for x. You get 3 times 8 plus 1 equals 5. The square root of 24 plus 1, the square root of 25 is equal to 5. Okay, and of course, we're talking about principal values now. We're not talking about positives and negatives. So that's what the answer is, and that works out very, very nicely. Okay, that's how you solve a radical equation. And here's another one I'd like you to try. I'm rewriting the equation. That's all I'm doing now. Now I just, I pretend that this is like at like 3x plus 2 equals 29. And the first thing I do is negative 2. And I get this. And then, again, if this were an x, the next step would be to divide by 3. And you get the square root of 2x minus 3.
you lower the camera.
Yeah, good. Thank you for telling me. So, we've brought over the negative 2. We've divided by 3. We have this left. And now we're going to square both sides of the equation. And that would give us 2x minus 3 equals 81. Positive 3, 2x equals 84. Divide by 2, and x is equal to 41.
It's 42.
That was my mistake. Right. Good. Who said that?
Sundust.
Yeah, wow, you are the star of the class today. The third root of 2x plus 7 is equal to 3. Okay? Dig your teeth into that one. What you need to do is to raise everything not to the second power, not squaring both sides of the equation, but cubing both sides of the equation, right? Because there's a 3 here. So, just the way, and that was that theorem that wasn't a theorem, I don't know what it was, a rule. The nth root of, x to the 9 of x to the nth root of x to the n is equal to x. So that could have been a 3, which turned out to be the third root. And this is not actually what I wanted to do. This is not, I wanted to go like this. Okay, so that's the way you would do it. And that's the way you would do it there as well. You get the 2x plus 7 equals 27. 3 to the third is 27. And then -7, 2x equals 20. And x is equal to 10. Okay, so that's pretty straightforward stuff. Are there any questions from anybody about any of this? Because now I want to give you a similar question that will be on the exam. So this is what the problem will be. Similar to something like this. So what are we up to? Problem 4, I guess, right? Is that problem 4? So here it is. Would you like to try this? I'm going to let you, well, how much time do we have? We have 25 minutes. I'll give you a few minutes just to take a look at it and see if you could do it. Okay, let's begin. So, again, I'm going to rewrite the equation. 3x minus 20 equals x minus 6. And I'm going to square both sides of the equation. That's the first step. This becomes 3x minus 20. This becomes x squared minus 12x plus 36. And now what we're doing is we're actually solving a quadratic equation. See, this is what we wind up with. So we want to gather together all the terms. And I would suggest, well, don't do it that way. Do it this way. Bring over the 3x, bring over the 3x, bring over a positive 20, bring over a positive 20. This is what you get. These drop out, leaving you with 0. That becomes x squared minus 15x plus 56. Okay, and what I'm going to do is a very simple moving of the equals 0 to the other side of the equation, which we're more used to. There it is. Now what do? You have 3 methods of solving an equation, and I will give you a hint. You never use the quadratic formula, and you never use completing the square. These are always factorable. Okay, so that's a hint. The hint is these are always factorable. So no matter what it looks like, and it may not, when you first look at it, you may say, wow, but it's factorable. So you would, x and x, the factors of 56, well, there are a lot of them. There's 1 in 56, there's 2 in 28. I don't know, does 3 go into it? I don't know, but it's 8 and 7. 8 times 7, right? You put the 8 here, you put the 7 there. They're both going to be negative. That'll work because -8 times -7 is positive 56. -8 plus -7 is -15. So that's good. Now you set each factor equal to 0. And x will equal 8 and x will equal 7. And we think these are the two answers. We think. Why do I say that? Why am I saying we think? Why, you know, what? You might say, well, what is he talking about? Well, at this point, you must check both solutions because all kinds of weird things can happen. Okay, so let's check. And take the original equation, 3x minus 20 equals x minus 6. And let's check the 7 first. Let's take the smaller of the two. So let's check the 7. So the square root of 3 times 7 minus 20 equals 7 minus 6. The square root of 21 minus 20 equals 1. The square root of 1 equals the square root of 1. That definitely makes sense. And 1 is equal to 1. And that's perfect, right? So that works out very nicely. It checks, you know, you're pretty confident. And now you go to the 8, all right, and you do the same thing. You write 3x minus 20 equals x minus 6. The square root of 3 times 8 minus 20 equals 8 minus 6. The square root of 24 minus 20 the square root of 4 equals 2. 2 is equal to 2. And that checks. So that works out very, very nicely. And that's how you do it. That's how you do this type of problem. And it's the whole thing. It's the whole thing. And we have time to do one more. Okay, because it is going to be on the test, and therefore it's something that we kind of need to practice. So are there any questions about this? No, I think it's pretty straightforward, actually. So let's do one now, okay? So let me write it, and then while I'm erasing the board, you could be doing the problem. So the next problem is going to be this one. The square root of x plus 9 is equal to x plus 7. Okay, so do this problem, write it down, and then I'm going to erase the board. And you could be doing that so we don't waste time, because we're running out of time rapidly, and I need to talk to the class about something. So let's, write that down, and I'm going to, meanwhile, erase the board. I'm afraid we're running out of time, so I need to kind of begin doing it. I'm sorry if you're not finished yet. I apologize for doing it, but we're running out of time and I need to kind of begin doing it. So that's the first step, as you know, and you get x plus 9. That has to be squared, and let me do it quickly. Okay, and then let's bring over the x, bring over the x, bring over the 9, bring over the 9, x squared plus 13x plus 40 is equal to 0. I'm kind of doing these rather quickly, so check my work. Just to make sure I'm not doing anything wrong. So not only did I do this, I made a mistake?
I don't know. I think so. For example, like I took off the x from x to x squared, but I might.
No, if the X belongs under the X.
Okay.
Same thing as you,
Yeah,
Professor,
okay.
same thing.
Anybody else find something wrong? This is
No,
what
same
happens
thing.
when you're working fast, you know, you'd have a tendency to mistake. Sandus?
No,
No, you didn't find anything. Okay, so here we go. So we factor this. And X, and what do you think? I think 8 and 5. Plus 5, plus 8. X equals -5, X equals -8. These are your two answers.
but you have to check.
Looks pretty good.
Yeah,
Other people got this?
yes.
All right, now, so that's the first part of the problem. But the second part of the problem now is to check this. So let's write the original equation, x plus 9 equals x plus 7. And let's try the -5. So we get the square root of -5 plus 9 is equal to -5 plus 7. The square root of 4 is equal to 2. 2 equals 2. Great, right? Everything is beautiful there. No problem. Great. And now we go to the -8 and we do the same thing. X plus 9 is equal to x plus 7. The square root of -8 plus 9 equals -8 plus 7. The square root of 1 is equal to, see that? That's not an answer. We've checked it and it doesn't check. Well, I knew this beforehand. I'm just being a little dramatic. Does not check. And when that happens in a problem, and I set this up purposely, then we say that -8 is not a solution to the equation. Or even better is to say that -8 is an extraneous solution. Extraneous solution. This is a key word that we're going to use a lot in this class. And there's the first time we're using it. When a solution does not check in the original equation, rather than saying you could say it's not a solution, but it's even better to say -8 is an extraneous solution, and therefore the only answer to this problem is, therefore, in mathematics, those 3 dots mean therefore x is equal to -5. And that's it, one solution.